So we have the concept of first-class functions. Nim supports closures as well as passing functions. There are two different syntaxes available for closures. Proc syntax, which is identical to regular procedure syntax, and do notation, which is a bit shorter. So let's see. Import some sequence utilities, and we create powers of 2, and we just define a sequence here. Okay, so we can echo, and we do powers of 2 dot filter do this. Okay, so I presume that the sequence utilities defines filter procedure that takes another procedure or whatever function that will actually be used as a filter, something that takes the integer in this case, because we're dealing with a sequence of integers, so it takes that integer and returns a boolean. So basically this, x is larger than 32, okay? And the other version would be to, okay, so basically call the filter as in we use parentheses and do the like, hey, this is a procedure of that type, right? Instead of specifying this into that. So this is like a little bit of, maybe a little bit like an arrow function, but not really. It's weird syntax, or just more classic and that. Okay, so this is the idea of closures. And I assume that you can use do only for procedures that take only the other procedure, right? But, you know, this is expecting only a closure and nothing else. Therefore, you can just do that. But in case if you would have, you know, filter takes the procedure and something else, it will be a bit different. Okay, makes sense. Or you could define the procedure already, right? And do echo powers of 2 filter and just give it that. Okay, let's take that code and play with it, because I don't know how much they will talk about it. So let's see, we have this thing, and when we look at filter, so it's a procedure that takes an open array, which is, you know, the powers of 2 in our case, and then it takes a predicament of the type, and it specifies here that it needs to be a closure. Okay, it's interesting that we can add that right here, like type, like here. Weird. And it returns the sequence. And I guess the whole thing is inline. Okay. So we have those two. Could I just do and provide a function? Nope. So you can't call it that way. You can only call it that way. Or what if I'll call it without anything? Oh, that works too. Okay. Okay. Again, I like skipping parentheses. It's so easy. What if I'll do comma? I guess it will be complaining that nothing was given here. Now it's saying it's a field because it isn't giving any arguments and nothing is here, right? Now it'll be like expected one or first mismatch position. Okay, this is getting confused. They definitely need to work more on how those errors are being, you know, where they're highlighting things, because it's a little bit confusing. Okay. But hey, I like that. Can we define something like that ourselves? Let's say we do something simple. Procedure, something like only odds, right? Just say odds, right? It will return odds. And it will we will be able to basically run it on let's say S is a sequence of integers, okay? And another argument will be the predicament, which is, and how did they define it here? Oh, okay, procedure of that type. Okay, which is a procedure. Okay, this is a bad example. Yeah, I'm just trying to think of defining something like filter, where we have one predicament and then we have some additional value that goes into this whole thing. Well, let's say that this will be, we'll call it super filter. Okay, takes a sequence of integer, we give it a predicament, which will be we have x, which is integer, and that will be procedure, which returns a bool. And did they do is closure, something like that? No, just closure. Okay, we have closure. And then we have one more, because we defined that it takes an argument of the sequence, the predicament, and let's do something else like always false, and it will be a boolean value, right? So that will be that, and that needs to return the sequence of integers. Okay, that's a long thing. So let's do it that way. This we've got, or not, let's clean up later. So the way this would work is that if always false, we just return an empty sequence, right? Else we do return s.filter, just give it a predicament. Okay, and let's do it without those. Okay, let's save it. It's declared but not used. Okay, so it's not complaining about anything. So now let's see how we can use those two syntaxes, but where we have more than one parameter. So let's do echo, and we'll wrap it here. Powers of 2, super filter, do, and we'll just copy this thing, right? But now it expects another parameter. So can I do just comma false? Save? Nope. Unreachable code after return statement. Oh, okay. Type mismatch. Okay. So this is unhappy. If I would do the whole thing with wrapping it, and no, we don't have to wrap it, right? Oh no, they wrapped it. Say we have procedure that does this, returns this, and equals x32, and then we'll give it false, and then close this one. Now it'll work. Okay, I see. So basically this do syntax will work only if that filter accepts, beyond the initial thing, it accepts only a single predicament and nothing else. If we need to add something else after it, it will fail. But let's try to just force it, okay? Ask AI why it doesn't work, because maybe there is another way, which is we haven't explained it yet. So let's do super filter, and we just need to do comma and say false. Okay, let's copy the code and ask AI like why. I have the following code. Paste it, we get rid of the first example because we want to focus only on our super filter. Okay, say why can't I call this thing? It's throwing errors at me. Let's see what happens. So far it seemed that we actually learned a lot here just by using AI. The reason you're getting an error when calling this line is because the do notation for anonymous procedures in NIM requires the procedure parameters to be specified using parentheses instead of a do keyword. Because the do notation, anonymous procedures, and it requires the procedure parameters to be specified using the instead of do keyword. This doesn't make any sense. Here's the corrected code. Okay, so it's basically, yep, ignores the whole do. Whatever. Replaced, which defines anonymous procedure using the parameters, return body syntax. So I guess this is something that we'll be learning. Yeah, so it basically wants us to convert it into that. Okay, the do notation is in different contexts such as iterators and for loops, but when defining an anonymous procedure as an argument, you need to use the type. Okay, it seems like it doesn't really know. It's confused. So let's keep reading. We experimented, all right? So the standard lib also makes a third option available by using macros. Import sugar. The sugar provides a arrow macro that simplifies writing type declarations. For example, character to character. So, okay. So this looks a bit more like arrow functions in JavaScript or C#, right? You don't have to say, hey, this is a function, or hey, this is a procedure. This is clear enough. So we can basically define a procedure map that we can map over a string. So I guess all the characters, and the function will be where it takes a character and returns a character. And the whole thing therefore returns a string when we map it afterwards. So it resembles it. Basically for every character in that string, we do and equals concatenate. What the hell? And sugar also provides this macro for the actual lambda value. And this will be, or C. Oh, so this is for defining the type. And this is for defining the actual declaration. Character, this, that. Line code is exactly equivalent. Foo map, we do procedure. Oh yeah, because we could do this procedure takes this, returns that, and bam, just increase something. While this is, yeah, okay. What is C in here? Character order +1. Oh, foo and turns into CPU. Okay, what is this? What does it do? Because it's like this returns a character. Oh, I see. Wow, I am so dumb. We're not modifying the initial string. We just take the result as a new string and we just add, because we concatenate at the end. So this is basically equivalent of add, the other character that we have. Okay, that makes sense. I'll do 26. We'll make them capital letters or something like that. Let's try it. Let's just do that. And let's make another procedure. And this will be to uppercase that takes character C and returns a character, right? And we'll just say, we just this whole thing just plus, why not, 26 or something, or like negative. So we could basically, let's get rid of that. And the echo, hello. Let's do it all lowercase. Dot map. And we have that C that we map to, and instead of defining that here, can we just do to uppercase? Oh, we could do that, and then we just give it a C, right? That'll be fine. So when we run it, whoa, that didn't work. H and then N. Oh, 30? Let's see what the difference is. Nope, 31. I think it'll be 32, right? There we go, 32. We made that. But this, when we have this defined, we don't need to do this whole thing. We can just do map and just give it that, right? Yeah, and that will work. Okay. That's cool. So with those macros, the gotcha is that when you're defining a type, you need to specify it with just a hyphen, with like a single arrow. While if it's the actual procedure that you're defining, the actual lambda, then you need to, that fits into that type, you need to define it with equal sign. Okay, makes sense. A little bit confusing, but I guess doable. You need to remember to import sugar, which is, I like when you don't need to import those things. But at the same time, it's funny that you can use a macro as something that's part of your language to basically modify how it works. I presume you could do that also in C and C++. It's just I never got to something like that. And I've heard that macros and templates in C++ are just horribly difficult to deal with.